Dividing monomials. So now we're going to look at some rules dealing with monomials, operations, where we're talking about division. We've been working with multiplication. Let's take a look at division. So quotient of powers. To divide two powers that have the same base, again, they have to have the same base, subtract their exponents and keep the base in the numerator. So our first example here, we're going to simplify this. X cubed y to the fourth over x squared y. Don't forget that that y has a 1 as the exponent there. So again, I'm going to just do this out the long way so you can see what's happening, but as you get more comfortable with this, do not write them out this way. I just want you to see what it looks like. So this is x cubed, x times x times x, y to the fourth, y times y times y times y, over x squared, x times x, and a y. So this is what it looks like if I wrote it out kind of blown up, expanded version. So how does that work? So what would happen here is that we could find common factors. So I could factor out an x from the numerator and the numerator. Dividing them both by a common factor leaves me with 1 in each of those places. I could cancel out these two. Those would factor out and leave me with 1s down there. I could factor out a y from each of these, and they'll leave me with 1s also. Notice I have nothing but 1s remaining in my denominator, so there aren't any other factors left to deal with. So that leaves me with an x, and a y, and a y, and a y. So y times y times y gives me y to the third. Notice that my denominator is just a 1, so that gives me x y to the third. So if we go back to our rule here and see how that would have played out if I just went straight from my original expression, I have x and x common bases here. I'm going to do 3 minus 2. We always subtract down just like we always do. 3 minus 2 gives me 1. So I'm going to put x as my base, 1 as my exponent. I'm going to put that in the numerator. So there's my x to the first power in the numerator. I have my y to the fourth, and then this is y to the first power. So 4 minus 3 gives me a base of y, an exponent of 3 in the numerator. So there's my numerator. And putting it in the numerator makes sense because if I do subtraction, when I do that, that leaves me with some bases in the numerator. That's where those bases will be when I do that subtraction and come up with a positive exponent there. So we could do our subtraction. We would still come up with x, y to the third. Again, I'm not expecting you to write it out this way when you start to get comfortable working with expressions. What I want you to do is just, if you get stuck, this is what you kind of think about how it works. All right, let's use the rule here to go to simplify this next one. J squared k to the 7th m to the 10th over j squared k to the 5th m to the 4th. So I'm going to look again for common bases. So I have my j's here. So I'm going to keep the j. I'm going to subtract the powers, the exponents here. 2 minus 2 gives me a j to the 0 power. K to the 7th. Actually, I'm going to back up here. This gives me j to the 0 power, but look what happens there. Those two basically just cancel each other out. It's a number divided by itself. So that really just gives me a 1. This is really just a 1 happening there. K to the 7th divided by k to the 5th. I keep my k in my numerator. 7 minus 5 gives me 2 as my exponent. I have my base of m's. I keep my m in my numerator. 10 divided by 4 gives me an exponent of 6. So I end up with k squared m to the 6th power. I have a 1 in my denominator. Again, it's that 1 that is there, but we don't really need to write it. All right, powers of a quotient. So again, we're continuing to look at our division here with our quotients, but let's bring that fraction up to a power. So I've got 5x fifth y over 6th, and I'm going to square that whole thing. Let's talk about the rule first, getting ahead of myself here. Power of a quotient. To find the power of a quotient, find the power of the numerator and the power of the denominator. So let's take a look at what that looks like. So I'm squaring this fraction, which really means, if I think about what it means to square something, it's the fraction times itself. So I really have a numerator times numerator and a denominator times denominator here. That really means that my numerator is multiplied times itself and my denominator is multiplied times itself. So I can just kind of, again, it's not distributive property, but it feels like that. I'm going to apply this exponent of 2 on the numerator. I'm also going to apply this exponent of 2 on my denominator. So 5x to the 5th y is squared, and in my denominator 6 is squared. So here I can apply those power of a product properties separately from each other. 5 squared, 25, x to the 5th squared, x to the 10th, y squared, y squared. 6 squared gives me 36. Don't forget our rules about simplifying our monomials. I want to make sure I have each base only once. Got it? No powers of powers. I'm good. Fractions are always simplified. 25 and 36. They're not common bases, but they're just an old school fraction. 25 over 36. They don't have any common factors, so they are the way they are. And no negative exponents, which we haven't gotten into yet. So check, check, check. Next one, 4x cubed over 5y to the fourth cubed. So again, I'm going to kind of apply that cubed to my numerator and my denominator here. I end up with 4x cubed cubed. I end up with 5y to the fourth cubed also. My numerator gives me 64x to the 9th power, and my denominator gives me 125y to the 12th power. Again, each base is written only once. I do not have any powers of powers. My fractions are all simplified, and I don't have any negative exponents. Good to go. And the last one, which has a few more pieces to it, negative a cubed b over 4a squared, and that is all cubed. So again, I'm going to cube my numerator, I'm going to cube my denominator. So I end up with negative 27. Notice that this is cubed. My negative is cubed, so I end up with a negative. Negative 27a to the 9th, b to the 3rd. And that is all over 64a to the 6th. Now remember our rules here. I only want to see each base once. So I have an a in the numerator and an a in the denominator. So I'm going to go back and use my quotients of power rules here. A to the 9th over a to the 6th means I can subtract those. I'm going to keep my base in my numerator. There's a in the numerator. 9 minus 6 gives me a exponent of 3. So I have negative 27a cubed, b cubed. My a in the 6th has been simplified out. So I'm just left with 64 in the denominator. Each base appears only once. I don't have any powers of powers. My fractions are all simplified. 27 64th, there's nothing I can do with that. And no negative exponents. Looking good. So applying our rules of simplifying our monomials, starting to work with quotients.